Scientists say climate change could be fueling storms like Hurricane Ian. The storm has officially met the National Hurricane Center's threshold for rapid intensification. That's when a storm swells quickly, gaining at least 35 miles an hour in wind speeds within 24 hours or less. For more, I want to bring in Phil Klotzbach. He's the research scientist in the Department of Atmospheric Science at Colorado State University. Phil, it's a simple starter question. What's the connection between climate change and hurricanes like this?
That's not necessarily a super simple question. So when it comes to climate change and hurricanes, I like to kind of basically start from what we know the best and then kind of step back to what we have a lot more uncertainty with. So with climate change and hurricanes, one of the big factors that we know is that sea levels are rising, and a few inches of sea level rise, for example, sea level's risen about 7 inches since 1900. While it doesn't necessarily seem like much to me out in Colorado, what that means is when that storm surge, so that wind-driven increase in water level that you get when these hurricanes make landfall, that means that that storm surge can penetrate farther inland. It can cause more inundation of houses and structures, and obviously that can increase the damage. Another thing we know generally is that with climate change, the atmosphere is going to be warmer, and a warmer atmosphere, being able to hold more moisture, can also yield more rainfall. There's a lot of kind of discussion and debate about whether storms are also going to be moving slower in the future. And if that is the case, slower moving storms, like we're seeing with Hurricane Ian, and obviously the poster child being Hurricane Harvey in 2017, slow moving storms obviously dump a lot of rain over a larger area, and that can obviously exacerbate flooding as well. When it comes to hurricane, basically how strong these hurricanes are, when we look historically, we haven't seen an increase in the number of hurricanes. Overall, we've actually seen a decrease globally in the number of hurricanes since about 1990. What we have seen is that hurricanes that do form are more likely to reach higher intensity. So these category 4 and 5 hurricanes. Obviously, Hurricane Ian was a pretty high-end category 4 hurricane when it ended up making landfall in Southwest Florida.
Phil, is the decrease in the number, and we'll get back to the question of intensity in a second, is the decrease in number, is that affected at all by climate change in some complicated way?
Yeah, and so when we look at storms, and we look at storms globally, we obviously have hurricanes in the Atlantic, but we also have hurricanes in the Eastern Pacific. They're called typhoons in the Western North Pacific, and the other parts of the globe, they're called tropical cyclones or cyclones. If we look globally at storms, the Atlantic has actually gone up since about 1990, but the Pacific has actually gone down. And since the Pacific is a much larger ocean basin, they get a lot more storms year after year. If you knock down the Pacific Ocean, basically the Atlantic can't make up the deficit that the Pacific generates. And a lot of that we think is actually due to a trend more towards La Nina. That's colder than normal water in the eastern and central tropical Pacific. Normally what that does is it increases Atlantic storms, decreases Pacific storms.
So what's your feeling as a last question about well, no, let me ask you about intensity, this rapid intensification classification. Is that something that's always been around, or even if there are fewer hurricanes, are there more that are rapidly intensifying as a result of this warming and sea level rise?
Yeah, so what we see with rapid intensification is if you look at, say, kind of the general definition that you listed before, 35 miles per hour or more in 24 hours, we haven't necessarily seen a global increase in that. But if you look at a higher intensity threshold, 60 miles per hour or more in 24 hours, so really, really rapid intensification, we do see a significant increase. And some of that is likely due to climate change that obviously warms the ocean surface, which provides more fuel for storms. But there is a negative with climate change as well in terms of hurricanes, and that is that you warm throughout the atmosphere at 10, 20, 30,000 feet. That warmer atmosphere tends to stabilize the atmosphere, which suppresses the thunderstorm development a bit. We think overall the warmer ocean temperatures are going to dominate, but overall, I'll say again, if you look at just kind of the general rapid intensification definition, we don't see a significant increase, but we do in the really high-end stuff. And that's kind of what we see with climate change in general is it's the extremes and the high-end extremes that are really what we're seeing the shifts in. And I think that's similar what we're seeing with hurricanes.
And briefly here at the end, Phil, what's your prediction about the 2022 Atlantic hurricane season? Is it going to be busy?
Yeah, so obviously the season, actually we had an extremely quiet August. It seems like a distant memory now. We actually had no storms in the Atlantic the entire month of August, the first time that had happened since 1997. September has been quite busy. Overall, October, November does look to generally be probably more active than normal, just given we still have the La Nina, colder water in the eastern and central tropical Pacific. That tends to reduce vertical wind shear, which is the change in wind direction and speed with height in the atmosphere and in the Atlantic. Too much of that shear tears apart hurricanes. So we think the shear is generally going to be lower. Also, we have very warm water in the Caribbean and tropical Atlantic, and that tends to kind of keep things going later into October and November.
All right, Phil Klotzbach, thank you so much for being with us.
Thanks so much for having me.